In this video, we'll be getting started with some of the more fundamental components you can use to interact with a microbit, those being a button, a switch, and a potentiometer. So I'm going to be using Tinkercad to design the circuit, and that's because Tinkercad actually has a circuit designer with a built-in microbit emulator. So all you have to do is go to Tinkercad, click Create, Circuits, and then in here, as you can see, we type in micro. You can grab a microbit with a breakout board, just like that. And then let me grab a breadboard. A button, and the button will place across the bridge. A slide switch, and the slide switch will place somewhere in the middle like that. And then I also want a potentiometer. Now the potentiometer I'm using in my actual circuit is a 10K pot. So I'm going to edit the value here to 10K. Okay, now we want to connect our power lines. So we'll do 3 volts to power. We will do ground to ground. Okay, so the pins we'll be using to interface with the buttons are 0, 1, and 2. 0, 1, and 2 are also analog in pins, which will be useful for the potentiometer since the values we'll be reading for the potentiometer vary. But as for the button, the way that you want to interface with the button is you can't just connect the button directly to the pins. Otherwise, you'll be shorting it directly to power or ground, and you'll be dumping a whole bunch of current through that. And that's one, really bad for your microbit, and two, it's a waste of power. So what you want to do is you'll take a resistor, and you can either set this resistor up in pull up or pull down configuration. So for the button, I'm going to set it up in the pull down configuration where it's going to be pulling the button state low when it's not being pressed. So I'm putting that in ground, and then it's coming to this leg here, and I'm going to pick off that signal from right here. So it's the same line as the as after the resistor. I'm going to pick off the signal, and I'm going to send that signal to pin 0. And then when the button is clicked, I want to attach a wire right here that goes to power. And so this will complete the circuit from ground through the resistor to power. And as you can see, that will pull up the 0 pin high. Now I'm going to do the same thing for the switch, except I'm going to put it in a pull down configuration. I'm going to connect that to pin 1. So we'll just go like this. Okay. And then that means that I need to connect ground to the common lead of the switch. Now I'm going to connect the potentiometer. So the potentiometer has a wiper on the inside, and this center pin right here gives you access to this wiper. We're going to drag across these 2 leads. There's a 10K resistor in here that varies in relation to the position of the wiper. So all you have to do pretty much is power both leads. So I'm going to send power there, and it doesn't really matter which direction you power them in. It will just switch the direction that the analog values change as you move the potentiometer. So then I'm just going to attach this to pin 2, which, like I said before, is an analog pin, and that's important if you want to read analog values from the potentiometer. So that's all the circuitry you need to get this started. And I'm going to actually go into the code and build a quick piece of code to simulate. So what I'm going to do is I'm going to print a bar graph on the the screen that's attached onto the microbit. Uh, and that's just how I'm going to display the values. And then I'll add a wait statement in between so that we can differentiate between the values. And then I'm going to go over to input. And again, this is just a test that my hardware works. I'm not going to be using this code when I actually implement it onto the real life microbit. So I'm going to do a read digital pin, and that'll be pin 0. So it'll be wrong place. So it'll be 0 to 1. So pretty much if it's 0, the screen will be dark. If it's 1, the entire screen will light up. And I'm going to do the exact same for pin 1. And then for the final pin, which is pin 2, I need to do a read analog, since that's the one the pot's connected to. And the maximum for analog is 1023. So it should vary from the bottom of the LED array to the top as I change the value of the potentiometer. So I changed the wait to 100 milliseconds for quicker updating of the values, and I'm just going to click Start Simulation. As you can see, it's flashing, and that's because the switch right here in the middle is off, but off in this case means that it's going to be pulled up, so that value is high right now. So if I turn this off, you'll see the screen goes dark. And then if I click the button over here and I hold it down, it has the exact same effect as if the switch is on. And then if I turn them both off, I can change the potentiometer and we can watch that value increase as I increase the value of the potentiometer. So now that I've verified the hardware works in the simulation, I'm going to write the code that I want to actually interface with the real life hardware. So the first thing is to include the microbit library, and that's so I can interface with the LED array on the microbit. So there's that. Now I'm going to assign my button position. So we do const int. I'm going to say button pin is equal to pin 0. And then I need to do that for the switch and also for the potentiometer. Okay, and then I also need to add variables for the states. So I'm going to initialize those as 0. Switch started fine. Let me do SS switch. And then pot. Perfect. Now we need to do our setup. So we need to microbit dot begin. That's going to initialize your microbit. And then we're going to do serial dot begin in case we need to do any type of debugging. And that baud rate is going to be 9600. And then we want to assign our pin modes. So pin mode for the button pin is going to be input, and that's going to be the same for all 3. So just go ahead and switch, and then this is pot. Okay, that should be enough for the setup. Now for the actual loop, I'm going to start with a delay, just in case. And now we want to read all the values from the inputs at the beginning of our loop. So we'll have button is equal to digital read, and we're going to be reading button pin. Then we have switch is going to be equal to digital of the switch pin. And then finally, the pot is going to be an analog read of the pot pin. Since the analog values vary from 0 to 1023, and I want to condense that to 0 to 5 LEDs, what I'm going to do is I'm just going to do pot is equal to pot divided by 200. And that should round since it's an int. So next, what I want to do is write some if statements so I can control the LED matrix based on the buttons. And so I'll do button. If it's high, what we'll do is we'll light up one line. So if button's equal to high, and I'm just going to copy and paste this. I have it in my notes right here. So it's just microbit.draw line, and then you pretty much just plot the line. And else, I'm going to turn that line off. So all you have to do is LED off. And now I'm going to do the exact same thing, but with a switch. And then we're going to change this so that the line that, so there's two separate lines. Okay, so now there should be two lines right next to each other. The first line should be controlled by the button. The second line should be controlled by the switch. Finally, I'm going to make a line that increases in length based off of the value of the potentiometer. So this is going to be the third line. And I'm going to have that based off of the pot value. So that will turn it off. And then, so we want the top half to be turned off, and then we want the bottom half to be turned on. So we'll do it like that, and then we need to reverse these positions, and that goes to 4. Oh, these should all be 4 actually. Okay, perfect. And then I'm just going to go ahead and check to see if there's any errors before compiling. Okay, there was a few syntax errors I had to fix. Other than that, we're good to go ahead and upload. So just by looking at the LED matrix, I realized there's something wrong with reading the buttons. So what I'm going to do is I'm just going to go ahead and start debugging with the serial monitor. So I'll do serial.println, and I'm going to read the potentiometer value. And then I'll upload that real quick. Okay, now that that's uploaded, I can go to Tools and I can go to Serial Monitor. And we can see I'm changing right now the potentiometer value and nothing is changing. I'm going to play with the other. Okay, so as you can see, right now I'm clicking the button and the value for the potentiometer is changing, which makes me think that something's wrong with my assignments. Yeah, there you can see I clearly forgot to change the pin assignments. So that should fix the problem now. So let me go to the serial monitor. Perfect, there we go. So now you can see as I change the potentiometer, the value varies. Here is the implementation of the circuit on an actual breadboard. As you can see, the leftmost line turns on and off when I click the button. The second line is on by default if the switch is off. So if I pull the switch on, it should pull down that value into pin 1. And as you can see, it turns off the second line. And now the third line will increase based on how I vary the potentiometer.